a series is given to you. Okay, this is a question from AP, right? Where some numbers, the series of numbers is given to you, where the first number of the series is root 2, right? And second is root 8, and third is root 18, fourth is root 32, like that. Okay, we need to find the sum of the series of these numbers, that is equal to what? If the numbers which we have considered over here for the series till n terms, okay, that means if these are in AP, we need to find the SN, that means equal to sum of n terms, that we need to find, right? Yes, so that we need to find, right? Now let us do one thing, whether these are in AP or not, that we need to find. How? Let us see. I'm writing the full form of AP, arithmetic progression, progression, right? Now here you can see root 8, if root 2 is the first term of AP, then it will be the written as A, which is equal to the first term of AP, right? And common difference, let us see and check whether the common difference is same for the series of numbers, for the series of this AP, right? Then to calculate D, the common difference, the common difference, we know that the common difference of an any AP will always be equal. That's why the difference between two successive terms will always be equal. That means if root 8 minus root 2, whatever the value it is, it will be same as root 18 minus root 8. It will be same as root 32 minus root 18, right? So let us check it. So whether AP or not. So to check this, we just subtract the first term from its successive term to get the common difference. So here, if root 8 minus root 2, if we are doing it, basically root 8 can be written as 2 times root 2, right? And minus root 2, which will be coming as 2 root 2 minus root 2, that is equal to root 2. So this will be the common difference. So the common difference is root 2, right? So when we checked for these two terms, now check the second common difference. That means to verify whether this is AP or not. So what we will do, we will take the third term and which is the and subtract the previous term from the third term. That means the second term to be subtracted. So then we can see whether this is AP or not. Root 18 can be written as 3392. So it can be written as 3 times root 2, because when 3 will be going inside the root, it will be 9. 9 into 2 will be 18. And root 8 can be written as 2 root 2, as we have seen earlier, minus 2 root 2. So this will be coming as root 2. So you can see the common difference is always same. So that's why we can say that the given series is in AP. Given series is in AP. To verify, let us check the fourth and third term, right? So when we subtract the fourth from the fourth term, the third term, what we'll get? We'll get the number that should be the same as the previous common differences, right? Because this is a basic property of an AP, that common differences should be same, right? So root 32 minus root 18 will give you 32. 32 can be written as 4 into 4 into 2. 4, 4, 16 into 2, 32. So it can be written as 4 times root 2. 32. Root 32 can be written as 4 root 2. And root 18 can be written as 3 times root 2, as we checked earlier. So 4 times root 2 minus 3 times root 2, this is equal to root 2. So you can see all these root 2, root 2, root 2, all these are the common differences. And all these are same. Mind it, students. All these are same. That means this is an common difference. D is same. Same means root 2. So that means we can say that the given series is AP. So now we have verified this, that this is in AP. Okay, AP. So we need to find the sum of n terms of this AP. So sum of n terms of an AP is given as, where A is the first term and D is the common difference, then Sn can be written as n by 2 into 2A plus n minus 1 into D. Yeah, this is the formula of the AP, sum of n terms of an AP, right? So we need to find the sum of n terms of the given series. So just put up the values. N by 2 will be as it is because there are n terms of this series. Okay, the count of number of terms is n. This is first term, second term, third term, fourth term, likewise till n term, till n terms, right? Now n by 2 into 2a, 2 times a. So a is root 2 because this is the first term of the series, because root 2 is a. You can see over here, first term. First term is root 2. So just put up the value 2 times root 2, right? Plus n minus 1 will be as it is because n is the number of terms of that series, our series, and d is the common difference which we have calculated, root 2, root 2, root 2, which are all are same. So just put the value of root 2 over here, right? Then what we will get? You will get, just let me slide the paper little upward so that you can able to see, equal to n by 2, right? 2 root 2 will be as it is, plus, just break this bracket, this will be n times root 2 minus root 2, right? So now you can see 2 times root 2 minus 1 root 2. Okay, if nothing is there, this is 1. 2 root 2 minus 1 root 2, this will be equal to root 2. So this will be coming as n by 2 times root 2 plus n root 2, right? When we take root 2 as common from these two terms, right? Root 2 can be taken as common, right? Then we can see n by 2 into root 2. Inside the bracket, we are left with 1 plus n, right? So here n times root 2 and here n by 2. So root these two can be written as n by root 2 into root 2 because 2 can be written as root 2 times root 2, and this root 2 is earlier which is taken as common, root 2, and inside the bracket 1 plus n, which can be written as n plus 1, right? Now you can see root 2 will be cancelled out, right? And we are left with what? N by n into n plus 1, right? N into n plus 1 divided by root 2. N into n plus 1 divided by root 2. So this is the sum of n terms. This is the value of sum of n terms of the given series which we checked as AP, and that AP was root 2 plus root 8, root 18, root 32, likewise till n terms. So to solve this, just quickly recapping the steps, that sum of n terms of any given series of n terms of any AP is given as n by 2 into 2a plus n minus 1 into d, where d is the common difference, but we are not knowing whether the given series is AP or not. So to verify that, what we did, we find the common difference between the two successive terms, these one, root 2 and root 8. So this is the common difference. That means from the successive term, subtract the previous term, you get the common difference. And from the successive term, if root 18 is the successive term, then root 8 is its previous term. If root 32 is the successive term, then root 32 is successive to root 18. So that's why we've calculated and find that in each and every step the common difference is coming as root 2. So that's why we verified, yeah, exactly, this is an AP, right? So if this is an AP, then sum of the n terms of AP will be n by 2 times 2a plus n minus 1 into d. That is the sum of the n terms of the given series of AP, right? And when we just put up the value and did the simple calculations, we find the value of sum of n terms of that AP as n into n plus 1 by root 2, which is our answer, so in this way, students, you can find it. If you find it useful, you can like and subscribe. Thank you so much for watching, students. Take care, and I will say, always put your queries and doubts into the comment box and go through the playlist through my channel, where you can see the various different concept based questions, and those will clarify your doubts and build up a very good concepts of each and every topic. For AP, there is a separate playlist where multiple questions are there. You can go through those questions. There are more than 20 to 30 questions. You can quickly go through and recap those questions to have a better command over the topic. Thank you so much for watching, students. Happy learning.